Hello everyone, welcome to Let's Go.xyz. In this video tutorial, we'll be discussing about best practices and data shaping uh, our data for machine learning. Okay, so in order to do that, I'll be using Audiologist dataset from UCL Machine Learning Repository. So first and foremost, I would like to credit the original owner of this data, who is Professor Jurgen at Bayer's College of Medicine. So if we look into this data, so we have 200 cases for training and 26 cases for testing our model. So it has 69 classes, 69 attributes plus a class or label attribute. Okay, so we have 24 different classes. In order to have a best machine learning output or accuracy, we have to have classes that has more frequency of occurrence. So if we take the classes that occurs only once, machine learning model can't learn these classes. So it's basically the accuracy is going to go down. So I'm actually going to limit myself to classes that has more than 10 frequencies of occurrences. So I'll be choosing this cochlear edge noise, cochlear post noise, cochlear unknown, and then normal here for our machine learning. Okay, let's have a look at the training data. So if we have a look at the training data, the format of the data is CSV, which is called comma separated value in a notepad. So when you download the data from UCL machine learning repository, it will be like this. So it should be in the same folder as where you write your Python script. If not, you have to specify the location, which we'll discuss in the code. And then if we look at the format of the data, it's all format of the data is comma separated value. The nature of the data is character. So we have a true, false, mild, normal, elevated, and all these. So we have to convert all these into a numerical value so that our machine learning model can understand. So we'll be learning how to pick the classes that has higher frequency of occurrence, how to convert all these character data into numerical data, and then how to reduce the dimension of this data from 69 to a number that gives us a better accuracy. For that, we'll be using a principal component analysis. So let's do all those things step by steps. Okay. Let me open the code. So here we have a function that's going to filter the labels that we want, the label that has high frequency of occurrence. So these 5 labels. The first and foremost, I have to load the data. In our case, the data has been already split into training and test data. So maybe if you have a look here, so have a test data and then the training data. So we could actually combine step 1 and 3. So where step 1 is loading the data and step 3 is to split them into training and test data. And so that's step 1 and 3. Maybe we can print out and see what happens. So can we read it without any problem? Yes, it seems we can. We'll close this. Execute again. So as you can see, wait. Yeah, fine. So as we can see, we have 200 rows, then 71 columns, where the first column is the index, and then the last column is the class. So we separate those two, we subtract those two, we will have 69 columns. Okay, which is features attributes. Then the last one is a class or label column, which we are going to predict. So now we have no problem in loading the data from the notepad. So now let's look into this function I've written, which is called a label filter. So in label filter, I'm basically passing the data that I've loaded from the notepad to the function. Okay, so and then I'm creating this empty list called f, and then I'm creating a for loop which is going to iterate from 0 up to the length or the number of rows in our data. Okay, if the data has 500 rows, it's going to iterate from 0 to 500 or 0 to 499. If it has in our case we only have 0 to 199 rows, so it's going to iterate 200 times. Then so I'm for every single iteration I'm going to check if the last column is cochlear unknown. If that's the case, pass. If it's cochlear age, pass. If it's cochlear age noise, pass. If it's normal here, pass. Else append that index to the empty list I've created here. Okay, then finally I'm using the drop function from pandas to drop all the rows that doesn't have these as our classes. Okay, so we could actually print this out and see step by step what's happening. So loading the data is not a problem. Maybe I should get rid of this one. Save F5. So this is after dropping, and this is before dropping. Before dropping, no, it's not before dropping, it's here. Before dropping we have 200 rows, and after dropping we have only 148 rows. So after dropping, if we look closer, the index is all a bit it looks randomized because we took off the rows that we don't want. So now we have to reset the index, which is actually happening here. Now we have to, so now let's go ahead and like print it out and see after dropping. After dropping we have 72 columns because after dropping and resetting we have 72 columns because the first one is the new index, which goes all the way up to 148, 147 because it starts from 0, and then the second one, this index column, is the old one, which goes all the way up to 200, but inconsistently, from 0 to 200. So now what I'm going to do is I'm going to drop this column from our data set. Go ahead, you could call it directly like this. So we have to see it right. Now if you see, we only have 71 columns, and that index column is gone. We don't have it anymore, but on top we have, right? So maybe we could also drop it by calling drop column 1. So if we see here, or this column has gone, which is column 1 here, so we have to call it like this. Okay, so we all learn by doing mistakes. So this is the right way of dropping the index column. Okay, we have to call the column by its header, which is index in this case, right? Okay, now if we look closer, after dropping, we come over here, we see this. So this, it's all question mark, so it's going to be of no use for us. So we just drop this 7th column. So we have to call the column by its header, which is 7, and then the axis x equals 1 says you drop it along the column. If it is 0, you drop it along the row. The 7th row will be dropped if you make it 0. Okay, so now we just print it out. So we will no more have that column 7 that has all the question marks. So we no more have that column 7. So that's pretty much for this video. In the next video, we'll learn how to map all these characters to a numerical value. So now we have 148 rows of classes that we want, that has high frequency of occurrence, and 70 columns, in which 69 of them are attributes, then one of them is column. So thanks for watching this video. Talk to you guys in the next video.